Okay, so we're going to talk about carbohydrates first. And carbohydrates are one of the 6 different types of nutrients. And that's one of the important things about studying nutrition is we look at the different nutrients, we look at sources of them, we look at what they do in the body. So I'm going to put carbohydrates right here. These are the 6 classes of essential nutrients. Can you give me any others?
Protein, fats.
Protein, good. Do we need to eat some fat?
Yes.
We do. Excellent. So we're going to say, I'm going to say lipids. That's a broader term, but that's basically includes fats. Anything else? We're going to be sending you more information on vitamins and minerals. Nice. Yep. Water. Okay. Now, which of these have calories?
Your carbs, protein, 2 and 3.
First 3, top 3, these have calories. All right, so this is how we get energy. Of those 3, where are you getting most of your energy from right now?
Carbs.
Fat. Fat.
So I missed that one.
We're burning fat right now. We are burning fat in this lecture. That's nice, right? No one's hyperventilating, so we're still good. We're still burning fat. As soon as something like oxygen becomes limiting, then you have to start switching over to carbohydrates. So for example, when you're doing your physical activity, when you start at rest, most of your calories, probably right now, probably 75% of your energy is coming from burning fat. Okay? Now, if you consume carbohydrate and your blood glucose goes up, you'll start burning more carbohydrate. But like when you went for your blood draws or came for your DEXA and you were fasted, you're burning almost exclusively fat. Okay? The other thing to keep in mind is the reason we put all of this together is the more muscle you have in general, the more fat you can burn. A resting muscle will even burn more fat. So that's why all of that kind of goes together. Now, of these 3, carbohydrates and fats are the most significant energy sources. In general, we get very little energy from protein. So it's not an important energy source. So we focus on the other 2 as far as energy. Okay? Now, kind of an interesting thing that our body can do is it can take, for example, protein and convert it to body fat. If you consume too much protein, in addition to too many calories. Have you ever heard that? What about protein and carbohydrate can do that? If you consume too many calories, too many carbohydrates, and or too much protein, they can be stored as body fat. In general, when you consume any of these, your body will do something with it. It will either burn them. If it can't burn those calories, it'll tend to store it as fat. Now, we have ways that we can modify that storage so that more of it will actually be stored as carbohydrate rather than fat. So we do things like exercise, and we time our nutrient delivery around exercise. So that when we do consume carbohydrate, it'll tend to be stored as carbohydrate rather than fat. So we'll talk more about that on tomorrow especially. Okay? So that's an important thing to keep in mind. Vitamins and minerals, no calories there, right? But they can really help in energy production. For example, B vitamins. You guys have heard that, like B complex and things like that. They're a class of vitamins that are really important in energy production. So sometimes you'll see that information somewhere. Okay, now these first three are also what we call macronutrients. These two are micronutrients. What's the difference between macro and micro? Larger amounts, right? These are macro because we need more in our diet and we store more in our body. So you'll see when we give you recommendations, these recommendations are going to be in grams. Some of these are going to be in milligrams. Some of these are going to be in micrograms, very small amounts. Okay? So macro versus micro. With that said, what do you think water would probably go under? Macro or micro? Macro. It's generally classified as a macronutrient. Absolutely essential. If any of these, if you're ever in a situation where you have to prioritize this, water is going to be your first priority. And then secondly, I would probably say protein, then carbohydrates, then probably your vitamins and minerals, then your fat. In general, we tend to store adequate amounts of body fat. And I know that as we get older, I get better at it. Okay? I think we're good so far. Now, one of the things that we want to do is, we're getting energy from these, but we also want to get nutrients from them as well. Okay, so we want to make sure we get as many nutrients as we can per calorie. If we're doing that, we consider that what's called a nutrient-dense diet. And that means nutrients per kcal. So the more of these that we get per calorie in general, the better. So if we're consuming things in our diet that are giving us calories but limited amounts of nutrients, that is not a nutrient-dense scenario, and that's not optimal, especially for you guys when you're doing physical activity. So that's where we come up with the term, that's an empty calorie. In other words, low amount of nutrients per kcal, and that's what we want to try to avoid. When these guys are setting up menus for you, we're avoiding that. An example of that could be something like sugar. Because sugar has sugar, carbohydrate, that's it. Okay? Even though it falls under the category of a carbohydrate, we want to try to get other sources of carbohydrate that have vitamins and minerals while we're getting those calories. Okay? So sugar's not, a lot of times it's labeled as the devil. It's not, but there can be better food sources. So we'll talk more about that as we go through this. Okay? So we'll abbreviate carbohydrates as CHOs because those are their atomic structure. They contain carbohydrates. They contain carbon, hydrogens, and oxygens. That's it. We're going to look at their structures. We'll talk about simple carbs, complex carbs, their digestion, absorption, lactose intolerance, because that's important for a person's nutrient profile. Glucose's role in the body and the health effects of sugar and starch and fiber. So carbohydrates in foods, what do they provide? Well, they provide bulk to the food. They provide sweetness, right? So carbohydrates tend to be a nutrient that tastes good, and they provide energy. In your diet, where should most of your calories come from? Carbohydrates. Approximately 45 to 65% of total calories, what we call kcals, should come from carbohydrate. Right? So when you see calorie on a label, we're talking about kcals. It's just a unit of energy or heat. Okay? That's where most of it should come from. And the main reason, it's the most versatile energy source. Okay? All of the cells in your body can get energy from carbohydrate. It's found in grains, legumes, fruits, vegetables, and milk. So it's in both plant products and animal products, right? Dairy products. We tend to get most of it from plants, but we can also get it from things like dairy products, and usually in the form of lactose. It's the main carbohydrate in there. Okay, so it can be a mix. Many of you guys heard any kind of bad press or bad connotations from eating too many whole grains. Right now there's information out there that says we might want to avoid whole grains because so many people are sensitive to gluten. Okay? A lot of that information is misinformation. In the original article, a lot of people don't realize this, the original article that came up with that term, gluten sensitivity, was retracted by the same group that did the original. They redid the study, reanalyzed the data, had better controls, and they said, sorry about that. It's really not a category like that. But by then it was already running downhill. And food industry and lots of industries have grabbed onto that, and now it's a multi-million-dollar business on making gluten-free items. So don't be afraid of whole grains unless you have a specific indication of why you shouldn't have them, like a blood test or something. Okay? So what are we going to talk about? Simple carbohydrates. You've probably heard that term. So what we call sugars. These are monosaccharides that are single sugars. We'll look at their structure in a second. And disaccharides. The most famous disaccharide is sucrose. That's what we call table sugar. So when you put sugar on something, you're putting sucrose on there. Sucrose is a disaccharide, but it is what's called a simple sugar. Okay? So in your diets that you get from your sports nutrition team, there will be some sugar in there, but it'll be limited. Okay? Complex carbohydrates, we've heard that, right? Starches and fibers. So things like polysaccharides, we'll look at that. These are larger molecules composed of straight or branched chains of monosaccharides. So the little single units linked together over and over again are what we call complex carbohydrates. Here's the simplest ones. Monosaccharides are single sugars. And I have the structure right here. Flashback to high school chemistry, maybe. All right? Does that look familiar at all? This little structure right here is glucose. Okay? And there's a variety of different ways of writing it. But this is what we call a single monosaccharide, or a single sugar. There's also fructose and galactose. Those are the three most common monosaccharides in our diet. Any of those stand out as being different from the others? Fructose, if you look at it, glucose has a 6-membered ring. Fructose is 5. Galactose is 5. So fructose is metabolized differently. Fructose is also sweeter than the others. It's a lot sweeter. And that's why it's in a lot of products. It's used as a sweetener. A little bit of fructose isn't bad. Too much fructose can be a problem. And so that's another reason why we limit sugar. We also try to limit what we call high fructose corn syrup. That's why that can be a problem, because it's in everything now. And if pretty soon you accumulate too much fructose in combination with too many calories, and that's when it's a problem. Fructose is more likely to be converted to body fat than any of the other carbohydrates. So we want to make sure we limit that. It also does some other things. But again, in moderation, we're fine. Too much is not good. So if, let's say, for example, if we think about childhood obesity right now and how common it's become, a bad scenario would be, for example, if one of those kids was consuming too many calories, they weren't exercising enough, and they were drinking too much soda or other types of sugars. It's likely in that child that fructose is going to be used to make body fat. And then pretty soon, if that happens for a while, they can be a candidate for type 2 diabetes. That's one of the reasons it's a problem now. Okay? So again, we want to kind of minimize, make sure we're taking in the right amount of calories. But we'll also see fructose in things like honey and fruits. There's no reason to limit fruits just because it has fructose in there. You still want to have fruits because it has lots of other nutrients in there as well, and things like fiber. Now here's lactose. Right, lactose, that's the carbohydrate in milk. It's got galactose and glucose combined, so it's what we call a disaccharide. More about that in a second. So complex carbohydrates. This is where most of your carbohydrates should come from. So these are glucose units linked together in general. A few of them linked together are called oligosaccharides. A lot of them are called polysaccharides. And they are in things like starches. This is one of the reasons we recommend starches, because it's a good source of glucose. So starch is the glucose storage form in plants. We store glucose as glycogen. That instrument that Nick used to measure your muscle glycogen, that's basically measuring the glucose in your muscle. And the reason that's important is because that's a great fuel source when you exercise. And I'll show you guys a video on that tomorrow. And then another type of polysaccharides can be fibers. So some fibers are carbohydrate. Okay? So in your notes, one of the things that you'd want to remember is glycogen is glucose that's stored in muscle and your liver. Okay. And we'll talk about what it does later on towards the end of this. And then starches is basically glucose stored in plants. So when you consume starches, you get glucose from that. So here's the structure of glycogen. Kind of looks like this. Each one of these little blue shapes is glucose. That's what that instrument detects by ultrasound. It's looking for this molecule in your muscle fibers. Because now when you get up and exercise, if you do high intensity exercise, this enzyme will start breaking off glucose molecules one at a time. And that's how you get your fuel during high intensity exercise. If you're doing anything near maximal exertion, you're burning glucose, mostly. So you need to store it ahead of that workout. So you got to make sure your diet's appropriate in order to do that. Otherwise, it's not there. If it's not there or you run out, what happens to your exercise intensity? It goes down. It has to. Because glucose can give you energy faster than fat can. Okay? So we don't eat glycogen. We eat things like starch, and our body converts it to glycogen. But they're kind of similar. Complex carbohydrates, we have dietary fibers. Provide structure in plants, that's what they're used for. They're typically kind of rigid molecules that give them structure. Obviously, they don't have a skeletal structure, so they use things like fibers to do that. They're soluble fibers. Have you heard of that? What's the difference between soluble and insoluble fibers?
One goes away and one doesn't.
What? Yeah, they go through our body differently.
One's absorbed, one isn't.
Insoluble fiber tends to stay intact all the way through. They'll tend to end up in the feces. Soluble fiber is better metabolized by bacteria in your gut. So it tends to be broken down not by us, but by the bacteria in our gut. And in general, that's their fuel source. And there's tons of research right now showing the effects of health from that bacteria that's in our gut. And the best thing we can do is try to maintain a good, healthy bacteria population in our gut, because they release molecules that go all through our body, and they affect lots of health indicators. We can't give them things like glucose because glucose is absorbed by us before it gets to the bacteria. So what do? We eat fiber. We don't absorb the fiber, but the bacteria can get it. And that's how we provide basically food or substrate for them. The simple definition is soluble fibers are soluble in water. So if you took this, if I had a source of soluble fiber and I put it in a tube of water and I put it in there and I invert it a few times, it'll turn into a gel because it's interacting with the water. If I take an insoluble fiber and I do that, really nothing will happen. That's the only difference. In our diet, we want a combination of both because they both have advantages. So we mix our fiber sources. So we consume things like oats, barley, legumes, fruits, and vegetables to get soluble fiber. One of the advantages is it can help lower blood cholesterol and help us control blood sugar. When we say blood sugar, what kind of sugar are we talking about? Glucose. You guys gave a blood sample. Fasting blood glucose is measured, so we're going to look at those values. And it's really important that we can regulate blood glucose. Soluble fiber is one way to help do that. Insoluble fibers, not digested, found in grains and vegetables, and especially grains, and it can alleviate constipation. It has other advantages as well. If we look at the overall structure, for example, here's starch. Each one of these is glucose. Here's the chemical bond linking those. Here's a very common fiber. Cellulose, have you guys all heard of that? It's all glucose. But look at the bond. It's different. We can't break that bond, but some of the bacteria in our gut can. And so they can get fuel from it. They can use that glucose where we can't. Okay? Some fiber sources. Plant foods, functional fibers are things that are types of fiber that are health benefiting, and they can be added sometimes to foods or supplements. So they have known health benefits, so sometimes you'll see that. And then total fiber includes all of that. One of the things that you guys might feel from your new diets, your gut might feel a little different because initially a lot of people don't eat enough fiber. And that's really important for your health. So your fiber intakes are likely going to increase. So the first maybe week or two that you're on that diet, you might feel differently. But if you stay with it, what's going to happen is those bacteria will adjust to that new type of food or substrate that they're getting. And it should, for the most part, you'll feel better after that. Okay? There's a lot of stuff on this slide. I'll go through it briefly. Now, as soon as you put carbohydrate in your mouth, digestion starts. Okay? So that saliva that's in your mouth has an enzyme that starts breaking down carbohydrate. So it happens immediately. That's why, for example, if you put a piece of bread in your mouth and you chew on it, the longer you chew it, it gets a little bit sweeter because that starch is actually breaking down and some of the glucose is now interacting with your taste buds. Okay? But in general, especially friends of mine, a couple of short little chomps and down the esophagus, right? Goes down this esophagus, which takes it through the central abdomen, through the diaphragm, into the stomach. As it goes into the stomach, it's going to start mixing with stomach contents. So the hydrochloric acid's released, and all of the food components start breaking down. Not much of that carbohydrate, if any, is absorbed through the stomach. Very little of it is digested at that point. Most digestion and absorption for all of the nutrients occurs in the small intestine. So once it gets into the small intestine, there are enzymes that start breaking down starch at a high level. Starts breaking it into molecules that can be absorbed. Okay? Some of that digestion takes place on the inside of the small intestine. Some of it takes place on the surface of the small intestine. So it's a combination. But you can eat a lot of carbohydrate and digest it in general, no problem. And then a lot of it will start going into the blood. Okay? What happens to fiber at that point? Not much, really, because we have most of our bacteria in our large intestine, not our small one. So the fiber will essentially keep going. So fiber will go through the small intestine, which is this, into the large intestine, and that's where we have most of our bacteria that can now start breaking down the fiber. So that's the trick of fiber. It goes through undigested until it gets into the large intestine. So now let's kind of follow that. Let's say you had, a classic example is oatmeal. If you guys have had any of that. It's going through your gut. It's gone through the small intestine, let's say. And now it's going to start going into the blood. So now we're absorbing it. So in small intestine, we have glucose and galactose. The monosaccharides start going into the cells. And then we have fructose that goes into the cells. That carbohydrate in that oatmeal is going to be digested slightly slower because there's fiber in there. So what it's doing is, rather than causing a big spike in blood glucose, it's kind of slowing that down. So you get a kind of a longer glucose response, and in general, that's good. So here's kind of an overview of this. This is what happens every time you have carbohydrate. In the small intestine, we have these kind of structures. Each one of these is a simple molecule of carbohydrate. They go through these intestinal cells right into your blood and start going through the tissues. Okay? Most of that carbohydrate is going to end up in the liver. So it goes into the liver, and the liver will take up all of the fructose. It'll take up all of the galactose, but it'll let some of the glucose go through. Why would it do that? One of the most important tissues in your body needs that glucose. Muscle and your brain. Brain and central nervous system relies heavily on glucose. That's its main fuel. Okay? So the liver lets some of that glucose go by so your brain and central nervous system can get it. Okay? Doesn't need fructose, doesn't need galactose, so the liver takes all of that. Lets glucose go. Some of it. Okay? Now, some of that fructose and galactose, probably most of it, are converted to glucose in the liver. Why? Because glucose is the most versatile energy source. We need glucose. We don't necessarily need fructose and galactose in our diet because we can make those from glucose. Okay. Next one, lactose intolerance. How many of you guys have heard of that? What is it?
Lactose.
You're missing the enzyme that produces that processes lactose.
Can't basically break down lactose because we lack an enzyme. And it's extremely common. I found out when I was lactose intolerant when I was 18 years old. I found out when I was on a baseball field.
Nice.
This wasn't right. And because I probably was drinking half a gallon of milk every day or something like that. And then one day I realized, yeah, I can't do that anymore. So I was in the restroom for a while. And then I finally realized, I think it's the milk. So I stopped doing that. And because I was getting headaches too. So I cut off the milk. And I realized, oh, that really fixed that. I had no idea what was going on. It wasn't as publicized as much then. And then when I started studying nutrition, I realized I might be able to drink some milk up to a certain amount. And in general, that's what people can do. You can kind of learn your limit. It's important, I think, that people realize what a good nutrient source milk is. It's hard to beat it for calcium. And it's hard to beat it for a vitamin D source, really, because it's fortified with vitamin D. So if a person is lactose intolerant, and in general, probably in the U.S., across the board, probably 75% of people are lactose intolerant. Sometimes they realize it, sometimes they don't. A lot of times you can have cheese or yogurt, but not straight milk, and sometimes ice cream or something like that. There tends to be a level. And the reason we tend to become lactose intolerant is, and you can tell I'm biased, and I'm trying to really sell this because I am lactose intolerant. The most important time in our life when we need milk is when? Infants, newborns rely exclusively on milk. So at that time, that enzyme is at its highest level. As we get older, generally teenage years, early 20s, that enzyme level drops off. We still make a little bit of it, but not as much. So what does that mean? We can kind of back off on that carbohydrate till we realize an amount that we can actually tolerate, and then we're fine.
Are we the only species that actually drinks milk as an adult?
I can't think of an exception. Mm-hmm. Yeah. Yep. Is that okay?
No.
Yeah. If other species could, they might.
They might.
Yeah. Yeah. Most of the data on that, on whether or not we shouldn't do that because no one else does, I'd say there's more arguments for the health benefits of dairy than there are against. Yeah. We do want to figure out things like what's in that milk. And I think that's absolutely needs further investigation. What kind of antibiotics and everything is actually in there? That is something that we need to pay attention to. But what happens is, if we don't absorb that lactose in our gut, it goes to the bacteria. Bacteria love it. So they'll actually metabolize that, and they'll make molecules that can cause diarrhea. because they'll make little molecules that cause water to go into the large intestine, and so it'll cause things like bloating, abdominal discomfort, and diarrhea. And sometimes it's more significant than other times. Sometimes it varies between people, so you have to look at it. So, for example, prevalence of lactose intolerance lowest in Scandinavians. It tends to run through descendancy or ethnicity on this. Highest in Southeast Asians and Native North Americans tends to be really high. And some of the populations more than 90%. But it's hard to tell. Like, for example, my brother and I are both lactose intolerant. My dad's in his 80s, drinks a lot of milk. Not a problem. My mom, lactose intolerant. So it just kind of depends. So here's what I was referring to. You got to be careful because, and I've heard some people say, well, if I drink more milk, I think I can build up that enzyme. You're not. You're learning your level of tolerance, basically. So you can mix dairy with other foods. Sometimes that helps. Spread dairy intake throughout the day. Use acidophilus milk because that's been fermented and a lot of that lactose has been broken down. You can use enzymes. So what do? I drink lactate, that milk. The downside is it's expensive. It's almost twice as much as regular milk. But I still drink quite a bit of it because it's got a lot of calcium in there and good protein sources. So you want to make sure if you can to try to look for other options because milk is a great source of calcium. It's got 300 milligrams per glass. It's really not a good substitute for that. It's fortified with vitamin D and it's got other things like riboflavin in there. Another thing you can do, how many of you guys have seen the little tablets? You can actually take lactase before you have it, and they've engineered that enzyme so that it's functional. Or you can actually take some of that lactase and put it in dairy products and let it break down the lactose. Okay, carbohydrate metabolism. This is something that's really in the press right now, and then some people think carbohydrates are not good for us. In general, we need to consider the amount of carbohydrates that are healthy for us on an individual basis. Okay, so we want to make sure that we realize they are valuable. But, for example, one of the downsides is, like some of the diets now, they'll have you cut down the first couple weeks down to less than 20 grams of carbohydrate a day. And when you go too low on carbohydrates, what happens is you make ketones. And we become what is called ketogenic, and we can enter ketosis. And that can eventually lead to a state called ketoacidosis, which is not beneficial. That's the accumulation of what are called ketone bodies in the blood, because an alternative fuel source during starvation are ketones. So it's kind of a survival mode for our metabolism. It can upset the acid-base balance, though, in our body, and our body employs mechanisms to try to maintain blood pH in that scenario. So the body can use glucose to make body fat when carbohydrates are consumed excessively. We went through that, but our body can also make body fat out of protein as well. So too much of any of them is not good. Okay? A couple more minutes, we'll be done with carbohydrates. Didn't even have some carbohydrates. Glucose in the body. Blood glucose. This is one of the most tightly regulated concentrations in our body. So our body's always attempting to maintain blood glucose within a specific range, and that's called glucose homeostasis or glucose regulation. If it drops too low, we call that hypoglycemia. And low blood glucose may cause dizziness and weakness. Hypoglycemia, a lot of people say, oh, I'm hypoglycemic. And a lot of times it's not that they're hypoglycemic, is that they're feeling like a carbohydrate crash. Because typically what we do is, let's say, for example, when you went for or when you came in for your DEXA, and let's say this is time, and this is blood glucose concentration. And let's say you started here, and it'll tend to stay within a range of about 70 to 110 mg per deciliter. So when you're fasting, it'll do this. Now let's say you eat something here, and it contains carbohydrate. What happens to blood glucose? Goes up. Goes through the intestinal cells, through the portal vein, through the liver, distributes to your tissues, including your fingertips. So if we did a finger prick, you'd see that. You guys had a blood draw. When you did that, your blood glucose is relatively low throughout your blood. Now you eat something and it does this. Why doesn't it keep going up? What keeps it from continue to go up?
Your activity level?
It can be, or one of the first things your body does is releases insulin. So the first tissue to really respond to that increase is the pancreas. So as soon as blood glucose is leaving the intestinal cells, it starts in two places. It'll go through the pancreas, and some of it will go to the liver. It's kind of an early signal system so that your tissues know blood glucose is going to go up. So what happens now? This is what should happen. It should drop. So now insulin is driving it down. How far is it going to drop? A lot of times it depends how far it went up. If it went up really high, how much insulin do you release? A lot. So now what happens? It's down there. How's that feel? Let me tell you what you feel sometimes when you eat a lot of carbohydrate. You're like, yeah, really lethargic. Why? This is part of it. So it did this. Drop below baseline. So now you're down here. Now what happens? Got another hormone. Got another hormone that drives it back up. Which hormone's that? Epinephrine will during physical activity or stress. What's another name for epinephrine? No, that's not it. Epinephrine is adrenaline. Physical activity, emotional, psychological stress can drive up adrenaline, and that increases blood glucose. Why is it doing that? Fight or flight, that's part of it for epinephrine. The other hormone that your pancreas releases is glucagon. So when your blood glucose drops, glucagon is released and takes it back to here in general. All day you're kind of doing that with blood glucose. Does that affect how you feel? It can. So what do? We kind of spread out our carbohydrates and try to make sure that we're not doing this all day, because that doesn't feel very good. And it's not healthy. In general, what we want is responses right through here. Okay? So that's one of the things that your diets are basically engineered to help change that blood glucose. There's one time that this is considered to be good. When would that be? Post-exercise. You want that to go up. Why? So that you have energy to exercise, but post-exercise, you have energy for the next workout. Because you want this glucose to go up and go into muscle. And when it goes up, which hormone goes up? Insulin. And insulin is probably the most important anabolic hormone we have. Insulin helps do things like increase muscle protein synthesis and decrease muscle protein breakdown. So what do? We use our diet to control insulin. And that helps us recover. So you'll notice on your diets, these guys, when they're going to put in a workout for you every day, and after that workout, they're going to make a recommendation that's part carbohydrate, part protein. Carbohydrate's going to provide fuel. Carbohydrate's going to increase insulin. The protein is providing substrate for the muscle tissue to actually repair. If you do not eat carbohydrate after your workout, muscle protein breakdown will continue to be accelerated. And you're actually in a state where you're losing muscle instead of gaining it. So we use our diet to control the hormones to recover from that. So we need insulin to work effectively. We want to try to avoid circumstances where insulin is not working effectively. And we call that insulin resistance, and we'll talk about that in 1 second. So that's most of what this slide is showing here. When you eat carbohydrate, blood glucose goes up. Pancreas releases insulin. Insulin should stimulate the uptake of glucose into cells, specifically into muscle. Muscle is the best glucose sink that we have. It's really important for helping us regulate blood glucose. So we want to make sure those muscles are there and they're sensitive to insulin. Okay? And then what happens is, as the blood glucose drops, here comes glucagon from the pancreas. And what glucagon does is, it taps into liver glucose. The liver is the only tissue that'll hold on to glucose until blood glucose drops, and then the liver will put glucose into the blood. So if you haven't had carbohydrates or anything to eat for a while right now, and you're fasted, what keeps this blood glucose from continuing to go down? Your liver's putting glucose into the blood. And that's what's keeping you in kind of a range that you can still continue to function. Okay? So this is going on all the time. So we want to make sure that all that's working appropriately. If it does not, there's a couple conditions that can occur. And those are called diabetes. You guys have all heard of diabetes. There's two main types. Type 1 is less common. Matter of fact, in the U.S., approximately how many diabetics are type 1? Have you ever heard this? Probably about 4 to 5%. Type 2, about 95% of diabetics in the U.S. Okay? More common. Now, prediabetes is when a person is starting to become type 2 diabetic. So type 1 is when a person is not producing insulin. And then generally, type 1, there's a genetic predisposition, and there's also an environmental stimuli. So in other words, some type of, generally they're thinking it's a bacterial infection, it's a viral infection, it's something that causes the pancreas to kind of attack itself. And it destroys, the immune system now destroys the part of the pancreas that makes insulin. And now we don't have insulin in the blood. If insulin is in the blood, it works. So what do type 1s do? They'll tend to inject insulin when needed. Okay? And that allows them to regulate blood glucose. That's how you do it. Type 2 is different. Strong genetic predisposition to type 2 as well. So genetics are involved in both. Type 2 is a little bit different though. Type 2 is a little bit more controlled as far as whether or not type 2 diabetes will occur. This is when fat and muscle cells actually become resistant to insulin. In other words, even if insulin goes up, blood glucose stays up. So what does the pancreas do? Release more insulin. What happens to blood glucose? Stays up. Why? I said a couple minutes ago, the best sink that we have for glucose is muscle. That requires insulin. If insulin's not working, muscles don't take it up. Glucose stays in the blood. And when that stays that way for a period of time, it starts causing harmful effects. Pancreas will only do that for so long, and then the pancreas will stop making that amount of insulin. So, the initial stage of becoming type 2 diabetic tends to be prediabetes. That's when blood glucose is high and insulin is high. The numbers are staggering. How many people live in the U.S. approximately? About 310 million, maybe 315 million, something like that. So a little over 300 million. How many people in this country are diabetic or pre-diabetic?
Probably over half.
65%.
Yeah, I'm willing to say 75, 80%.
It's actually not that bad. This is good.
Notice it
Feel
more
better.
in kids.
What's that?
I notice it more now in kids too.
Yeah, the kids, we used to call type 2 diabetic, it used to be called adult onset. Because most times as we got older, we'd get it. Now we don't call it that anymore. We just call it type 2 because so many children have it, so many kids have it. And it's a combination of things, including not enough physical activity, too many calories, and the wrong type of calories. And that sets them up for that. Unfortunately, if they go through pre-diabetes and they become type 2 diabetic, there's not really it's very, very unlikely it's going to revert back to normal control of blood glucose. There's something like 120, almost 120 million people in this country that are pre-diabetic and type 2 diabetic. Okay? If those pre-diabetics do not do something to change their lifestyle, they're on their way to becoming type 2 diabetic. Okay? So it's very important that an individual screens their fasting blood glucose and monitors that to see if pre-diabetes is an issue. If a person's pre-diabetic and they change their diet, they change their lifestyle, They change their body composition. They do everything they can. Sometimes they can revert back to normal glucose levels and glucose homeostasis. Very few people, though, know they're fasting blood glucose, and everyone should. Everyone should know that and should monitor that. But that's kind of, and that's going on all over the world. It's other parts of the world, it's going through the roof as well. So it's really important that, especially in our profession, we try to make sure as many people realize that as possible. Okay? So one of the keys we have to remember is, carbohydrates are very versatile, good part of our diet, but we have to make sure that it's the right amount of carbohydrate for each person. A couple more slides and we're done with carbohydrates. Recommended intakes of sugars. The USDA food guide states that added sugars can be included in the diet as part of discretionary calories. In other words, small amounts are okay. Dietary guidelines state to limit the intake of foods and beverages that are high in added sugars. These are what are called dietary reference intakes. Added some sugars contribute no more than 25% of a day's total energy intake. For some people, it's close to half. Okay? This is the World Health Organization, and FAO suggests greater than 10% of energy. Some parts of the world, it's not as much of a problem. This is fiber. This is what one of the things I didn't mention in fiber. But for example, one of the things that fiber can do is it can decrease this big increase. So if you consume something that has glucose in it, but it also has fiber, it'll tend to do this. And that's what we want. We want a moderate blood glucose response unless it's post-exercise. And that's what this is talking about. Reduce the risk of type 2 diabetes, decreasing glucose absorption, or slowing it, basically, that I should say. It can also enhance the health of the GI tract from the fiber. Then block absorption of unwanted particles, may protect against colon cancer by removing potential cancer-causing agents from the body. So in general, your fiber intakes will have quite a few different mechanisms for protection. Questions on this? Okay, if we could, let's take about a 5-minute break, and then we'll do the next one.
Are you going to be covering the muscle?